Hadouken!
Prove me wrong, and that'd be great.
Damn, I'm good.
You've got to take big chances in order for the potential for a big positive.
Hello, welcome back to A Boring Revolution, your number one news source for everything in regards to the Boring Company. Hope you're all well. Sorry about the long wait for a video. I've been extremely busy with a few other projects, but I have had quite a few requests in regards to talk about Prufrock-2 and Prufrock-3 and the kind of metrics behind them and why it is somewhat problematic, but all these things can be overcome. So let's get into the video. So basically, the metrics surrounding Prufrock-2 and especially Prufrock-3 are absolutely bonkers. It's ludicrous. And I'm not talking about the ludicrous that sits behind Plaid in terms of the Tesla Model S and Model X, but actually kind of ludicrous in terms of how they kind of pan out if you were to deliver a system like this in the kind of medium to long term. That doesn't mean it's not doable, but in terms of kind of making it work logistically, it is fairly difficult. So I've pulled up this image because I think this is a good kind of illustration of how the Boring Company builds its tunnels, and you've got a nice little cross section there. You don't usually see it like this. So you can see all the segments there. As you can see, 5 segments per ring. Each segment is about 1.4 meters wide, approximately. So it's, you know, it's a pretty standard setup for a TBM. We kind of know from previous construction works how these things are assembled, but the actual workings behind the scene in terms of the TBM are going to be fairly different when it comes to Prufrock-2 and Prufrock-3. So a lot of people have said to me, like, how is it that you can't like visualize the actual metrics behind Prufrock-2 and Prufrock-3? And the reason is I have ran the numbers and they are bonkers, absolutely bonkers, and I'll show you them now. So first of all, let's kind of give you the numbers, as it were, and how it kind of lines up. So this is extracted from a recent press release that has come from the Boring Company, and it just kind of gives you an illustration of what they're trying to achieve. So the current iteration of Prufrock, called Prufrock-2, is designed to mine at up to 1 mile per week, which I've always said is very, very doable, and I can see a path forward for that. Although, again, still the metrics are quite crazy, but doable, meaning a tunnel the length of the Las Vegas Strip, approximately 4 miles, can be completed in a month. Prufrock-3 is designed to be even faster. So in terms of Prufrock-3, I struggle to visualize this, really do. Because we're quite a way away from actually, you know, delivering something close to Prufrock-3. We've essentially not delivered Prufrock-2 yet, so it remains to be seen how close they can get to these kind of metrics that they're aiming for. So Prufrock-3 is designed to be even faster, with the medium-term goal of 1/10 the speed of a human walking, or 7 miles per day. In the short term, if each Prufrock-2 mines at 1 mile per week and the Boring Company produces 1 new Prufrock machine per month, then the Boring Company will be introducing 600 miles per year of capacity. That is a massive amount of infrastructure that you can then exploit for business purposes, and ultimately it's going to pay for itself in under 5 years. So if you could keep building more and more miles of underground tunnel, you know, you've got a very stable, reliable and profitable business there. So just to kind of break it down into kind of metric and imperial units, so we've got 1 mile per week is approximately just under 230 meters per day, or 755 feet. 7 miles per week is 1,609 meters per day. So that is a lot more, like a ton more, and that makes a big difference. 5,280 feet. So looking at that, you would already, you know, come to the conclusion that is a lot of work to do that in a week. Never mind do this in a day. So what are the actual metrics behind that in terms of like how it's constructed and what happens to all the materials that you remove from the tunnel itself as you're creating that void? Before we do that, let's just have a quick look at in terms of the metrics of the standard tunnel design for the Boeing company. So one of the best things the Boeing company has done is they've said this is the size of the tunnel. We're not going to change it. We've set our design parameters, and this is what it's going to stay at, possibly forever. I personally think it should be a little bit bigger than this, just a tiny little bit bigger. But if they're going to stick to that, then fair play. It's definitely doable. I just think there's advantages to having a tunnel that's got an internal diameter of around 12 foot 9 inches, in my personal opinion, in terms of fitting shipping containers and various other vehicles. But if you intend just to use it for kind of passenger vehicles, 12 foot is more than enough. Possibly you could go smaller than that. So we've got 9 inches thick, 12 foot, and external diameter 13.5 foot. So again, 13 foot 6 inches and 4.12 meters. 9 inches is 230 millimeters, just under that. And I've just added this here because I'm using a lot of measurements in meters, which is basically how we should measure everything. I've put it in cubic feet as well. So 1 cubic meter is 35.315 cubic feet. So let's have a look. So the most kind of important kind of processes in a TBM, the two most important processes are assembling the concrete segments. So you have kind of like a manipulator, and that installs the segments in order. You have 5 segments in a ring, on an erector. I know people like to call it an erector, but it's basically the same thing. So the erector installs the segments into a ring, and then when that's all bolted into place, you've got kind of a stable structural element, and then you kind of bolt the next segments into that previous ring, so it's all one kind of connected, interconnected unit. So as you can see, you've got a very, very large stack of segments here. A typical ring will have 4 of these and then a key segment, so you're looking at that. So this is like essentially two ring beams in this particular section here, and then you have 2 keystones as well, and spoil as well. So the other kind of critical process that the TBM is completing is obviously cutting away the face of the rock or the ground, as it were, the strata, and then removing that out from the face and then out the back of the machine. That's a very, very critical element. What happens behind the machine is also very, very critical, and that's something I don't believe the Boeing company has thought about when it is looked at these metrics. Maybe they have a whole process behind the TBM, but I've not heard anything yet, so we have to kind of speculate about that. But that is a very important process. So spoil heaps, as you can see, can be 12, 13, 14, maybe even 15 meters tall. Whether they would let you do that in a densely built kind of urban area, I very, very much doubt that. So you'd have to have a process to remove that spoil almost as quickly as you're sending it out the back of the tunnel. And the same goes for concrete segments. You'd have to have them manufactured, ready to go, and stacked on site, ready to send into the tunnel. So you're sending concrete segments into the tunnel, and then you're removing spoil from out of the tunnel. So those two processes need to be both in harmony with one another. Otherwise, you're going to get stoppages with your machine. So let's kind of break that. So this is kind of the scary thing. The scary thing about these particular machines is just the volume of material that you both need to supply and remove from that construction site every single hour, and of course it mounts up over the course of a day. So for version 2 it's very, very difficult to visualize, but version 3 is almost impossible. The reason for that is just the sheer volume of material that you're moving per hour. It's absolutely insane. So yeah, if you ever watched my videos of the Las Vegas Convention Center loop construction process, you'll have seen that large amounts of spoil were building up on site, and that was being removed pretty much every couple of hours, let's say every few hours then. But that process was causing bottlenecks. So For Prufrock version 2, you're talking nearly 8-9 times as much spoil as a Godot, and that per hour is 153 cubic meters of spoil. So to calculate that for a full day, you times that by 20 hours. Why 20 hours, Will? Well, because in these calculations, I've assumed that Prufrock will be down for around 4 hours per day on average, keyword on average, for maintenance. All tunnel boring machines require maintenance pretty often. So they may have made some improvements in terms of how often they need to maintain particular elements of the machine, specifically the cutter head, but I can't really see a way past that where you're not, closing the machine down for at least 4 hours per day. So it's an absolute monster amount of spoil that for Prufrock-2, 153 cubic meters. Multiple numbers of trucks are going to have to come in and move that. Pretty much over a week of that kind of collecting on site, things will become unworkable, so you need to constantly remove that. And that also includes 41 concrete segments per hour. Yes, per hour. 41 concrete segments is massive amounts of tonnage of concrete that needs to be kind of manufactured and then molded into your segments, and then it needs to be there on site, ready to go, shipped into the tunnel. And obviously the length of that tunnel is changing constantly, so the longer the tunnel, the longer your supply lines, the more segments you need to have stored in the machine. So it all becomes very, very difficult to logistically run that. So 41 segments per hour is around 16.92 cubic meters. This is accurate to within about 5%, I'd say. 16.92 cubic meters of concrete. That's reinforced concrete, by the way. So that includes reinforcements in that particular measurement. Prufrock version 3 is just, the metrics are absolutely crackerjack. I really just look at this and just trying to visualize how this would operate on a site, and how the supply chain would kind of operate, and the logistics of bringing out that spoil and at the same time then bringing in your concrete segments. And it seems excessively difficult, really, really very, very difficult, because not only are you removing well over 1,000 cubic meters of spoil per hour, so remember this is for a full day, that's times 20, you then on top of that need to move 287 concrete segments into that tunnel and have them ready to be assembled, and on top of that you've got to assemble them. So again, you've got to increase the speed of that assembler, that erector. So all these processes, extremely difficult to do these kinds of things. You're going to have a very, very well organized machine that basically works like a factory, basically a fully automated factory, because there's no other way you could do that. You couldn't do that with people in the mix, as it were. It need to be fully automated. Nothing like this has ever, even V2 has ever been achieved, even just for an hour. It's miles ahead of everything that's ever been attempted in this industry. Do I think Prufrock version 2 is doable? Absolutely, and I've been saying that for many years now. I can visualize the process of getting up to 230 meters per day, and I think that's very, very doable. I did an episode in the past where I said it could get up to around that, maybe slightly short of that number, but it would take 7 or 8 years and potentially of iterations. But Prufrock version 3, which I presume is coming in the very long term, would be a whole different kind of beast. Every process would have to be changed and adapted, and you might have to duplicate processes as well inside the machine. I suspect it would be a much longer TBM as well to get anywhere close to this. Potentially 300, 400, maybe even 500 meters long. it'd be very, very difficult. I think it's achievable to get somewhere in between 2 and 3, maybe like 500, maybe 500 meters, 600 meters per day. But I don't think that is achievable 7 days a week. I think you would have periods where you'd have to basically restock the machine and shut it down for long periods of essential maintenance and kind of clearing out the spoil that's on site. There's many unanswered questions, but as you can see from these metrics, write down in the comments below how insane are these numbers. Really quite insane. And this here doesn't include over excavation in soft ground. So in soft ground you might lose 10 to 15% extra on top because additional material is falling into your TBM from above in the in front of the cutter head. So again, it's crazy stuff. It really is crazy stuff. But I don't want to say it's impossible, but I think that they should have focused on Prufrock version 2 prior to putting out these metrics for Prufrock version 3, because it just seems too far away. It just seems like it's not a doable thing. Once they do version 2 and they achieve that 230 meters, I believe then after that maybe people could start visualizing it and seeing it as realistic. But at this moment in time, it seems a long way away, and that leads to me to some very key questions that I need kind of answering, as it were. So one of the most important processes that you will learn about in the construction industry is the curing of concrete. If you've ever worked on a site where you're literally pouring things in situ, then you will be very aware of the importance of the curing process, the importance of kind of weather and the processes of actually pouring the concrete and formwork and that sort of thing. And it's drilled into your head fairly regularly that you need kind of like 28 days. The number they give you is 28 days, but it's not necessarily that long. I've put here 20 days. So what I'm trying to tell you here is concrete segments need to be produced in advance of being used. So at least 20 days in advance, maybe more, maybe like 24 days. If they're produced in advance and they're in a yard curing, you therefore need 20 plus days of supply. Where is that going to be stored? Because ideally you want that concrete segment kind of manufacturing yard to be very close to your tunnel, and trying to find a 7, 8, maybe 9 acre site in the middle of Las Vegas that can do this is going to be quite a problem. I'm not saying it's impossible, but it's definitely an issue that needs to be resolved prior to tunneling even beginning. Another question that I would like to kind of see the answer to, or get a hint as to what the answer is from the Boring Company: can that compound manufacture 6,000 concrete segments per day if it wants to do Prufrock-3? That is a lot of work. That is, it's going to have to be, again, a very fully automated process. The reason I've said 6,000 is often some segments have issues, so you need to be manufacturing more than what you need. Plus, there may be a day, maybe there's a day where you have a power cut or some kind of other issue. Maybe you run out of cement because of some kind of local supply issue. You need to have segments ready in advance just in case you have a shortfall, maybe for a day or half a day, something like that. So you need to be doing 6,000 per day. Now that is a big ask. I can't think of anything even close to that that's being attempted in terms of manufacturing precast concrete units. And especially the kind of quality control that you need for these kind of structural elements. Where will the spoil be stored, both short term and long term? This is an even bigger problem. So obviously you're going to be storing some of the spoil on site, so you're going to need a large site area like you did Las Vegas, but maybe much bigger. And then you're also going to need to then move that spoil from the construction site to a long-term storage area. Now, it's possible that you could have maybe another kind of system for moving it to that area, maybe a train, or maybe some kind of a large dumper truck that kind of moves it across sites. But again, that needs to be established as to how you're going to do that, because you're going to be moving hundreds of cubic meters every day, hundreds and hundreds of cubic meters every day from your short-term storage compound to your long-term storage compound. Now, what happens to that? Well, that could obviously be used in other construction processes for kind of bases to roads, foundations, hardcore MOT, that kind of thing, even in dams, reservoirs. Now, it could be used for other things depending on what kind of geology you're going through. But again, that's a big problem you need to fix, because you're going to need hundreds of acres to store this long term. Maybe you let it dry out in the sun, then maybe you convert it into bricks. I always thought the bricks idea was a good idea, but the water content of that spoil is critical. If you could dry out that spoil, then convert it into bricks, that would be exceedingly useful. But again, these are issues that need to be resolved prior to construction starting. What is the cost of storing and transporting 100,000 cubic meters of spoil off-site? You know, are you going to have to buy a plot of land? How much is that going to cost in Las Vegas? You know, land is at a premium in most parts of Las Vegas, so you're going to have to go way outside the city limits. Then how much is it going to cost you to transport that there? You know, 100,000 cubic meters for like a 4.5 mile tunnel. That's an insane amount of spoil. Insane amount, and you're going to have to do something with it, because you can't leave it to build up. So again, these questions could do with being answered by the Boring Company. It's a lot easier to manage this when it's Prufrock version 2, as it's not coming out as fast. But when you've got Prufrock version 3, it builds up an insane level. How many semi-trucks are needed to transport the above? You know, you might need 5-6 semi-trucks, you know, just constantly running, 24 hours a day in between these two sites. That probably means you need like 12 drivers, because you're going to have 2 shifts, if not 3 shifts. That's going to obviously incur a cost. What roads are they going to use? Are people going to be happy for all these massive semi-trucks using the roads? Again, another issue. Could you maybe use something else? Could you maybe use some kind of narrow gauge railway and move it, you know, in large carriages, something like that? There's lots and lots of questions here that need answering. If you think you have answers to these questions, please drop it in the comments below. I think I have a few solutions here, which I will talk about in a future video. But the metrics are absolutely bonkers, ludicrous, insane, and it's just visualizing how this process will work is just really difficult for me. And I've worked in the industry for many years, and I don't not necessarily worked in the tunneling industry, but I understand logistics of sites and how they operate, and excavations and groundworks and things like that. So if it's difficult for me to imagine this, then I'm hoping that it's quite difficult for many other people as well outside the industry, and maybe even the Boring Company team themselves. But as they say, every challenge is an opportunity. Let's see what the Boring Company come up with, and maybe they'll surprise us with some really innovative solutions to the following questions. Okay guys, that was kind of the video. I want to thank you all for tuning in. Hope you enjoyed it. Please do like and subscribe if you've not already done so, and comment on the video if you had answers to the questions. If you have questions about the calculations, please drop a comment and I'll try and explain it to you. Remember, I've included 4 hours for maintenance, so it's a 20-hour work day, as it were. Please follow me on the following platforms if you can, please. Patreons, as always, thank you very much. I do appreciate your wonderful support. Here they are, wonderful people. Thank you so much. And yeah, thanks for coming on the video with me and following this quite incredible set of numbers that blow your mind, literally blow your mind. Hope you enjoyed that, and I guess we will see you on the next one. Take care now, and goodbye.
お前はもう死んでいる。何？